I have uploaded in YouTube, so you can watch again the course yesterday. So if you have any question or something like that, you can ask.
Okay, thank you, sir.
In the course time, in the lecture time, also in tutorial time. Okay, we will discuss about potential. Potential. Let's say N. Okay, I just give you an example for point charge particle.
Sir, sorry to interrupt. Hamadi said he had a problem with his connection.
Okay. Okay, thank you. Point charge. This is Q, for example. So we have the electric field as we derive in the last lecture, last week, yeah, last week or last yesterday. We have Q1 over 4p epsilon 0 r squared r hat. Okay, so this is the unit vector. Unit vector means equal the magnitude of the vector is 1. Okay, so this electric charge, we could introduce it, for example, let's say the magnitude here. The magnitude is Q. Okay. So this could be expressed, this one, okay, Q 4 pi epsilon 0 r. Okay, this is, you have already learned about or studied about differential, yeah? Differential properties. So this should be minus here. It's additional. Okay. So this could be happen if we consider the case of electrostatic. This could be defined or introduce something like that. Introduce if E doesn't depend on time. Means that we have electrostatic. Electrostatic, something like that. Okay. So this, I will write, okay, minus d over dr over 4 pi epsilon r. Okay, this, so you see that I could also, what is it? Okay, I'll forget it, okay. So this functional, we call it potential. Functional. So in electrostatic, we have two quantities usually. We have vector, this is the electric charge, and potential. Okay, so this is basically a rough definition of, or non-formal, maybe not rough, non-formal definition of the potential functional. So formally, we could introduce such potential functional usually via using a definition about energy and so definition of potential is introduced using of your energy. Let's see. Oh yeah. Energy and work theory. Okay. What does it mean? If you know about work is defined as F dot S. So F here is force, and this one is displacement. So somehow, if you consider a curve, for example, this is a force F. Okay. So this is, for example, its displacement. This could also proportional to the V, yeah, V dt. Okay, as you know from the column laws, that in this case, F is equal to the test charge times E. Yeah. This E here coming from the source charge. Source charge. Okay. Source charge could be a point particle or n charges or a sphere or anything else. Okay. So if we put in, we substitute this F into this equation, this R equation, substitute to this equation, so we will get that is W, the work, is equal to Q dot dr. Okay. So this basically, it has the below, the boundary below is let's say Ri, Rf. Okay. And this one equals to Q minus delta V. Okay, delta V means the difference between VRF minus VRI. Okay. So this is the potential. This one we call it this potential energy. So basically, the potential energy, let's say, this Y, yeah, this Y, okay, is U, sorry. U is the symbol is U. U Q times V. So this is the energy potential, potential energy. Okay. We could make an example. For example, yeah, a point particle. Point particle. Let's see. E Q over V squared. This one, if R dot dr, okay, it should be Q over 4 pi epsilon 0 m squared dr. So if you integral I to Rf, E R, this is minus Q over 4 pi epsilon 0 R from Ri to Rf, okay? So it should be minus Q over 4 pi epsilon Rf over minus 4 pi epsilon 0 Ri. Okay. So this is minus delta V. Okay. So that's why in general, the definition of the potential, we get this minus Ri to Rf, sorry. So this is the definition of potential. Potential difference. Let's say this VRF minus VRI. Okay. So usually this one, Ri, we call it a point of reference. So if we talk about the potential, it depends on how you set or manage this point of reference. I will give an example. Okay, I will give you an example. Is there any question for this this lecture so far?
What's potential functional?
Sorry?
Potential functional. What's that?
What is that? So this is the definition of potential functional. This V here, V. Here. This one. This V here, V is potential functional.
I mean, how is that different from potential energy?
Oh, okay. The difference between potential functional and potential energy. Okay, that's your question. Okay, good. So the potential energy, you just have, let's say, U is QV. So this Q here, usually a test charge. Charge. And this one is from source. Okay, so if we consider the delta U here, the difference, the potential energy difference, delta U. So delta is always URF final minus URI initial. So final minus initial. So delta, that does it mean? Okay. So this means Q delta V. So this is energy. Okay, is that clear?
Okay, that's clear. Thank you.
Okay, yeah. Welcome. Anything else? Okay. Let's say, okay, let us consider a charge, for example, yeah? A point charge. Example. Sorry. One charge. Okay, the potential. So we have a source, for example, capital Q. Okay. This, let's say, it lies in the origin, and then we consider the field with this distance r, this vector positional vector arrow. And then, so we know that this E here is Q over 4 pi epsilon 0. So the magnitude, yeah, the magnitude of the electric field, okay? So delta V here is minus Ri, Rf, Q over 4 pi epsilon 0 R squared dr. As you see that this equals to minus plus here. So this is minus Q over 4 pi epsilon 0 R Rf. So we will get, sorry, this is a minus. Okay, so this is plus, right? Q over 4 pi epsilon 0 Rf minus Q over 4 pi epsilon 0 Ri. Okay? So this equals to Okay. Okay. So from this expression, you can directly, well, intuitively, we could say that this VR from like this. Okay, you agree? Directly from this expression, the above expression. Okay, but you could also add a constant here. Okay, the difference also the same. So this is a constant. So these constants is determined by a setting or setup. Yeah, the value of this C constant depends on your choice. Depend on the choice. For example, I could take, if R to infinity, okay, this V infinity, this is 0 plus constant. So this is C. Yeah. You could also, for example, take equal 0, this C, okay? Then we get VR R, okay? Or you could also take anything. You don't have setting it to 0, for example. C. And let's say this is non-zero. It's okay, that's fine. Should be Q 4 pi epsilon 0 plus C. Yeah, C is, let's say, yeah, this is equal to V at infinity. Okay, that's the example for point particle. Any question? Any question? So this constant, you can set anything. It's a real number from minus infinity to plus infinity. You can set anything. But usually in the point particle, usually we took this formulation, okay? Because easier to use. That's the reason. But in voltmeter, if you want to measure the potential, the voltmeter measures only the difference. So the difference of the potential difference. Okay, so it doesn't, well, important you choose this constant. It's up to you. I mean, it's not so important how this C looks like. I mean, the value of C is not so important in this case, because in voltmeter you measure only the potential difference. Okay, that's why if we talk about potential, you need also a point of reference. So in this case, for point particle, charged point particle, so usually we use this one. But in problems, for example, in examination, in the exam, we could also set this C is non-zero. Okay, it depends. Any question?
Sir,
Yes.
is there any rule to determine the constant, sir?
Sorry?
Is there any rules to determine the constant, sir? Or is it just provided?
It's arbitrary. It depends. It depends on the problem. Okay, it's depend on you. Yeah, roughly you can set anything as long as it's real number.
I see, sir. Thank you.
Okay. But in point particle, charge point particle, we use like this one is what I checklist here. Okay, for point particle. So I will give you an example again. This is also immersed in the examination maybe 2 years ago, something like that. Or appear in the, let's say you have thin sphere, charged thin sphere. Charged thin sphere. Okay, like this. We have the radius r here. This is 1, this is 2. We know that this E1 here is 0, okay? In E2 here is Q over 4 pi epsilon r squared. Again, for this is r greater or equal to capital R. So for example, I could also use like this V here, yeah, because it looks like similar to, well, not similar, the same as the point particle. We could also took this Q P to R is 4 pi epsilon 0 R plus C. Okay, C, let's say, well, I replace it by V to infinity, at infinity, okay? Sorry, let's say just write C, okay? For example, again, we could use Fi2 at infinity. If this is 0, then we get C equals 0. This 1i, 2i. We could also, for example, this is equal to Q over 4 pi epsilon 0 R. Okay. We could also this one. So if this is the case, so this F2 R is Q equals to Q4 over 4 pi epsilon 0 R plus Q over 4 pi epsilon 0. Okay. Well, you can make any choice. You can make any choice. This one is V2 R Q over 4. Of course, these two cases is different here because we have the boundary value we have set is different. So, but they are different, but they have the same potential difference. Okay, they have the same potential difference. So this is the important things. Important things. Okay, it doesn't matter how the form of the potential. The important thing is the potential difference. They give the same form of potential difference. Any question? Sorry, there is should be minus here, for example. Yeah. This should be minus, for example. So this V2, the sphere surface is 0. Yeah. But at infinity, they are negative. Okay. But this is in the second model. Yeah. For V2 is, for example, minus Q. For this one is non-zero. This V2 at the surface. Yeah. Pi epsilon 0. Any question?
Sir,
Yes?
can we have an example, sir? Because I cannot imagine when do we use the C is 0 or C is minus Q.
It depends on the problem. This is the problem. This is the example I give. I give it to you. This is the example. So if you set at the infinity, for example, it's minus Q over 4 pi epsilon 0 R, and then you get the potential at the surface, at the sphere surface, this will be 0. But in the first model, it's non-zero, okay? But at the infinity is 0.
Okay.
Okay, it doesn't matter, as I said, that it doesn't matter the form of this potential, but what matters is the difference, okay? Because the difference, what we measure is the difference, the potential difference. The potential difference is the same. I mean, this equal to Q over 4 pi epsilon 0. Yeah, let's say RF minus RI. They have the same potential difference. So this is the important things, this one. But not the form of the potential. Okay? So if we talk about the potential, usually we talk about the potential difference in reality, not the form of the potential. Oh yes, I forgot to mention yesterday, the units of the electric field, the units of electric field is Newton per Coulomb. Okay, so the unit of potential is Newton meter per column. So this is joule on column. So this is called volt. Volt. Okay. Any question again? So this is the potential function also. For potential energy, So because this is energy, this is joule. Okay. Because this U here is Q times V. Okay, that is the lecture today. Anything in mind? Question? Or should I summarize in Indonesian, bahasa Indonesia?
Is this part not a part of the, what do you call it, the tutorial number 1, electric potential?
Tutorial, let me see. So the tutorial module 1, it's about electric force and electric field. So usually this module is about Coulomb's law, force, and everything. Yeah, there is no potential. Maybe in the second module. In the second module.
All right.
Yeah.
I think it should be fine if you want to explain in bahasa now.
Well, the time is off. The time is up. Okay, maybe 5 minutes ya. Oke, saya akan jelaskan dalam bahasa Indonesia. Jadi yang kita pelajari sekarang itu tentang potensial energi dan fungsi potensial, atau disebut namanya kalau bahasa potensial saja. Bedanya tuh apa? Bedanya nanti kita lihat kalau energi potensial itu satuannya joule, kalau potensial energi satuannya volt atau joule per kolom ya. Nah, ini saya ambil contoh untuk partikel titik ya, muatan partikel titik ya. Ini fungsi medan listriknya ya gitu ya. Kemudian ini besarnya yang ini. Oke. Nah, jadi khusus untuk partikel titik ini itu bisa kita nyatakan bahwa E di sini sebagai turunan ya. Turunan dari sebuah yang namanya disebut fungsi potensial. Nanti yang akan kita lihat adalah V di sini, yang ini. Jadi fungsi potensial ini dikhususkan untuk elektrostatik. Jadi artinya bahwa medan listriknya tidak bergantung pada waktu. Itu elektrostatik. Nah, definisi potensial itu baik potensial energi maupun fungsi potensial itu dimulai dari teorema usaha dan energi ya, bahwa W di sini itu sama dengan integral F dot ds gitu ya. Nah, kalau kita tahu bahwa gaya dari hukum Coulomb ya, bahwa gaya elektrostatik itu adalah Q muatan uji atau test charge itu dikalikan dengan E di situ itu adalah medan listrik yang berasal dari muatan sumber. Oke. Nah, jadi kalau itu saya integralkan, itu akan saya dapatkan di sini bahwa integral F dr itu sama dengan integral QE dot dr. Jadi ini sama dengan Q kali minus delta V. Jadi saya tulis pakai minus. Nah, jadi contohnya kenapa itu di situ perlu minus, itu saya ambil contoh untuk yang partikel titik tadi ya. Kalau saya integrasikan di sini, ini jadi dia minus. Jadi delta itu selalu akhir dikurangi awal. Oke, jadi delta itu selalu akhir dikurangi awal. Jadi VRF dikurangi VRI. Jadi dapat seperti ini. Nah, bisa saya simpulkan bahwa delta V di sini itu sama dengan minus ini. Walaupun saya turunkan itu untuk kasus khusus, ya, yaitu untuk partikel titik, tapi rumusan ini tuh berlaku secara umum, gitu. Dengan kata lain bahwa ini adalah definisi potensial secara umum atau beda potensial secara umum. Dan beda potensial itu sendiri sangat bergantung pada titik acuan. Oke, jadi bentuk potensialnya itu tidak penting bagi kita. Yang paling penting itu adalah bedanya, the difference, beda potensial. Karena beda potensial itu yang diukur nanti oleh alat yang namanya voltmeter. Seperti listrik dari udara, dari langit itu, adanya petir gitu, itu kan karena yang di atas itu lebih positif, di bawah lebih negatif. Nah, negatif itu di bumi itu dia netral, makanya dia ground kita sebutnya. Jadi makanya listrik itu bisa mengalir seperti itu. Nah, listrik mengalir itu adanya beda potensial, bukan karena potensialnya sendiri. Kalau potensialnya tegangannya sama sih tidak akan ada aliran muatan. Jadi aliran muatan itu terjadi ketika ada beda potensial. Makanya beda potensial itu yang penting di situ, bukan bentuk potensialnya. Oke. Nah, hubungan antara energi potensial dengan fungsi potensial itu cuma tinggal dikalikan ini saja. U di sini adalah energi potensial, V di sini adalah disebut fungsi potensial. Jadi tinggal U sama dengan Q kali V saja. Jadi kalau delta U itu sama dengan Q kali delta V. Ini ambil contohnya misalkan seperti di muatan titik ya. Ini contohnya misalkan saya bisa mengambil misalkan untuk di tahingga dia potensialnya 0. Sehingga kalau dia itu 0 itu berarti C-nya sama dengan 0. Bentuk potensial menjadi seperti ini. Kalau misalkan saya ambilnya itu yang lain, misalkan sembarang saya tidak 0, ya bentuknya ada C di sini. Ya C di sini itu adalah bebas, tergantung kita mau ngapain. Tapi dalam hal ini bergantung pada persoalan ya, soalnya seperti apa gitu ya. Nah, ini contohnya mungkin lebih jelas lagi kalau untuk yang di kulit bola tipis ya. Jadi kulit bola tipis itu saya bisa mengambil fungsi potensialnya sama dengan yang di atas tadi, yaitu C-nya sama dengan 0, artinya bahwa potensialita hingga ini sama dengan 0. Jadi C-nya sama dengan 0, sehingga fungsi potensialnya jadi seperti ini. Oke. Sedangkan untuk yang lainnya, misalkan contohnya yang pernah keluar itu, kalau dia itu di tahingga, disetting seperti ini. Jadi sehingga dapatnya seperti ini. Nah, sekarang potensial di permukaan bolanya gimana? Kalau saya setting R-nya sama dengan R besar, ya berarti kan ini 0. Artinya apa? Di tahingganya negatif, tapi di permukaan bolanya tuh 0. Oke? Bedanya sama aja kalau kita ambil bedanya antara misalkan ini di tahingga, ini di R gitu, beda potensialnya sama. Tidak masalah. Oke, itu dari saya. Ada ya absen jangan lupa ya, saya sampai jam 2. Kemudian untuk yang modal ini saya nggak bisa pakai enrollment key ya, saya lagi tanya kenapa nggak bisa gitu. Ya palingan sih kalau nggak bisa palingan melalui Teams saja begitu. Nanti akan saya usahakan ada lah. Ya. Tapi paling itu cuma ini aja. Ya apa istilahnya? Formalitas, saya nggak tahu formalitas kalau itu apa, saya nggak ngerti. Oke, itu aja ya. Terima kasih. Nanti video ini akan saya upload ke YouTube ya, Anda silakan lihat lagi. Terima kasih. Selamat siang semua.
Terima kasih Pak. Selamat siang.
Terima kasih, Pak.
Pak, makasih Pak.